What's up everyone, welcome back. In this question, you're trying to estimate the mean average grade for a university course where the population standard deviation is 15%. You take a sample of students and their grades are given below, right? So you took a sample of a bunch of students, got their grades for this university course, and now you have to find a 90% confidence interval. So notice, similar scenario to the previous two questions, only difference is instead of given the sample information, like the sample mean, sample standard deviation, we're now given the actual data in the sample. So first thing to always recognize is, are you given the population standard deviation or not? And notice in this question we are. We're given the population standard deviation. So the population standard deviation is known. So same thing, to get this confidence interval, because the population standard deviation is known, we know we're going to use the Z distribution. Now if you remember in the questions before, what I was doing was I was writing out all the parameters that were given, like the X bar, S bar, etc., etc. Notice in this case, we're not really given too many parameters. We're going to have to find them. So what I'm going to do first in this question is actually write out the format for the confidence interval when the standard deviation is known. So it's the sample mean plus or minus the z-score subscript alpha over 2 times the standard, the population standard deviation over the square root of the sample. So notice that we are not given this sample mean. That's the first thing. What we're going to have to do is we're going to have to find it from here. And the way you would do that is you would sum all of these numbers up. So if you sum all of them up, you would get 504. And then you're going to divide it by the sample size. So notice the sample size in this case, 1, 2, 3, 4, 5, 6, 7. Right? So you're going to divide this by 7. So we know one of the parameters is n is equal to 7, which is important because we're going to have to plug that in over there. So 504 divided by 7, that's X bar, that's the sample mean, and that's going to give you 72, right? So notice we have this and we have this now. So X bar 72 plus or minus, what's the alpha in this case going to be? The alpha, if you remember, it's 1 minus the confidence percentage, and the confidence percentage is 90% in this case. So 1 minus 0.9, that gives us 0.1. And so this alpha over 2, we're going to be looking for the Z score. Alpha over 2 is going to be 0.05. So the Z score, where to the right of that Z score, the area under the graph is going to be 0.05. The probability is going to be 0.05 to the right of it, right? If you remember, this area over here is going to be 0.05 if we're looking for the Z score with a subscript 0.05. And so to the left of it, it's going to be 0.95. So we're going to have to look that up in the table. And then the population standard deviation, that is given as 15 over the square root of n. N is 7, right? There are 7 observations. You sampled 7 students. So this would be the square root of 7. Now to look up this z-score in the z table, I wrote out the portion that you have to look at right here. So you got to look at the row 1.6, and then it's going to be between the columns 0.04, 0.05. Notice how the probability is 0.9495 and 0.9505. And that gives us the probability to the left of a certain z-score. And notice 0.95, that's what we're looking for. And notice 0.95, it's right in the middle of 0.9495 and 0.9505. So the z-score, we know it's going to be 1.6. And then what's the middle between 0.04 and 0.05? You could add those up, 0.04 plus 0.05, which gives you 0.09, divided by 2, which would give you 0.045. Right? So between 0.04 and 0.05 is like, I'll write it over here, it's like 0.045. And then notice that 0.95 is going to be sort of in the middle of these two, right? 0.9495, 0.9505. So if you want to be more exact with the z-score, you could sort of interpolate it, right? So you'd get 1.645. So that's the z-score over here. So to the right of 1.645 is this 0.05, which represents that subscript there. And then to the left is 0.95, and we have to get the 0.95 to use the table. So basically over here, this is going to be 1.645. So when you do all of that in the calculator, you'd end up getting 72 plus or minus this margin of error over here, 9.3263, and then you can make the interval from that. So that there is the 90% confidence interval. So not too bad of a process. The only difference between this question and a previous example where the population standard deviation was known is that you have to actually find this sample mean over here to plug in. But it's not too bad. You just sum everything up, divide it by the sample size. And if you're to use the stats calculator main menu, you'd go to stat. And then what's going to be different about this versus the previous examples is that you're going to see columns for like list 1, list 2, list 3, list 4. And you could input the list at this point. So you could input all of these in one of the columns. So you would put this under list 1. Doesn't really matter which list, but if your list 1 is empty, you can just input all of these here. So it should go all the way up to 7. So after you input the list, then you hit F4, right? So that's going to be INTR, which is short form for interval, confidence interval. F1, because we're using the Z distribution since the population standard deviation is known. And then we're doing it for one sample. And then you're going to get to this here. And you got to make sure that this data over here says list. Before we were putting in variable, but now we want to refer to the list to get all of the data. Confidence level is going to be 0.9. And then the standard deviation, that is given as what? 15. And then there's going to be also another input here, list. And then you could just specify that you're looking at list 1. And when you execute all of that, you should get this same confidence interval here. It may not be the exact same numbers, like the third and fourth decimal places might be different because this is actually rounded if we bring it, if we get it from the table. But nevertheless, it should be very close. So you should see like 62.67, 81.33. That should be the confidence interval if you use the table and if you use the calculator.